Bless you. So the directions were for you to copy the examples. Here they are. And then for you to do the guided practice problems. So you should have attempted both of these. Thumbs up if you were able to do 1A and 1B. Okay. So example 1, not as difficult as example 4. Example 4 was pretty tricky. So your calculator does a lot of this work for you. You have to show work to get credit. So this is confusing the way they broke this down. I'm going to break it down a little bit different. If I had to rewrite 27, I look at my list of perfect square factors, and I think, does 27 divide by any of these? And it divides by 9. So I rewrite 27 as negative 9 times 3 because it's the same thing. And the square root of 9 is 3, so I square root it and I put it on the outside. And since it was negative, I put an I with it. So the result, 3i square root of 3. So the same thing they did here. They just broke it down a lot longer. So 1a. I look at 18 and I think, does 18 divide by any of these numbers? Divides by 9. So I rewrite 18 as 9 times 2. The square root of 9 again is 3. Since it's negative, I write I with it. And that's how we get the result, 3i square root 2. This is simplest radical form. No decimals will be accepted. What's your question, Mark?
You also write it as the square root of negative 1 times 3 squared times 2.
Yeah, you write it out like that. So 125, I look at the list and I think, does 125 divide by any of these numbers? Here, 125 divided by 25. 25 times 5 is the same as 125. So I'm just rewriting it using a perfect square factor. And the square root of 25 is 5. Since it's negative, I write I with it. And there's still this number that I did not cross out stuck under the radical bar. And that's all the work that I need to see, just like that. So you're going to treat this I like a variable most of the time. The only time you don't treat it like a variable is when you square it and it turns to negative 1. So for 2i, 3 times 4 is 12. I times I is I squared. Always replace I squared with negative 1. So 12 times negative 1, negative 12. Okay. 2b, there's a lot of ways to mess 2b up. The main one is to multiply. What's 20 times 12? Did anybody do 20 times 12? What's 20 times 12? 240. Right. So your answer doesn't have a negative in it. So there's like just something really tricky about this. When it comes to multiplying radicals, if they are negative, you have to simplify before you multiply. Or your answer will always come out positive, and then you'll have to factor that was a negative. This is your number. I'm gonna look at this list of perfect square numbers that actually do square root. 27 doesn't square root, so I'm gonna look and see if any of these smaller numbers divide into 27. 27 divides by 9. So I wrote it. Oh, is it 18?
Yeah.
Sorry. So 18 divides by 9. So you write it as 9 times 2. You actually square root the 9 by putting a 3 on the outside. The square root of 9 is 3. If there's negative, you take the negative out. You just write an I. And the I just shows anybody reading your math that you square rooted a negative. It's the 2 stuck underneath. So for 20 divides by 4. So I'm going to rewrite 20 as 4 times 5. And for 12, I'm going to rewrite it as 4 times 3. This is the same as 20, and this is the same as 12. But these numbers can be simplified, so they're better. So when I square root negative 4, I put a 2i on the outside of both of these. Now when you multiply radicals, you multiply the numbers outside. I'm going to do outside times outside, and I get 4i squared. And then I do the inside times the inside, and I get 15. Radicand times the radicand. Take the I squared out and replace it with negative 1, because that's just a fact. I squared is negative 1. And you get negative 4 square root 15. We've got a question on 2b. We're going to spend more time on that. And not a ton, but. Okay. All right, 2c. You guys spend a lot of time in pre-algebra and algebra going over rules of exponents. You probably had no idea why. Well, breaking down I with an exponent is one use of rules of exponents. Only I squared. Only I squared. If you have I squared come up in your problem, you replace it with negative 1. So what mathematicians will do in complicated problems where they're square rooting negatives is they will on purpose create I squared so that they can take the imaginary part out and make it real again. So we'll multiply I into a problem just to make it real again by making an I squared. Alright, so here this is just number tricks. Getting used to exponents and thinking about the power of rewriting numbers. So I to the 31st is the same as I to the 30th times I. Everybody agree that's I to the 31st. Try to agree with this? Is this the same as this? Or these are the same thing? This has an invisible 1. When you multiply the same base, you add exponents. These are equivalent. I'm going to do another one. I to the 30th is the same as I squared to the 15th. So I've broken down 30, and instead of having a power of 30, I have I squared to the 15th, and that makes 30, because that's power of power, you multiply exponent. I squared is negative 1. Negative 1 to the 15th, you can use a calculator, just understand your negative numbers. It's just negative 1 times I, negative I. Rewriting exponents in order to simplify. too. You gotta be able to do these two. Now number 4 is extra. Number 4 is extra, I'll admit. But number 3 you have to be able to do. This is a quadratic. We could graph it and it would be a parabola. Okay, the rest of this stuff was just randomness. But we could graph this and get a parabola and connect it to the equation for Friday. One. I'll go over in a second. So then I'm trying to get x alone, so I would subtract 100 from both sides. And 4x squared equals negative 100, and then divide by 4. And you get x squared is negative 25. And anytime you solve by square rooting, square root both sides, you get x is plus or minus 5i. Why is it plus or minus? Well, I'm going to use a simpler example. Let's say that it was positive 25. Aubrey, what could x be here? Like, scenario-wise, what would make this true? Well, 5 squared is 25. Also, negative 5 squared is 25, right? So when you're solving by square rooting, you show that it could be a positive or negative using this plus or minus sign. That's solving by square rooting, plus or minus. Are you good on that, Mark? Yeah. Well, because we square rooted a negative. But look, what does this look like? So the y-intercept of this parabola is at 100, right? That's C. The y-intercept is at 100. So if I go by 10, this is 50. This is 100. This parabola looks like this. It opens up because it's positive, and the y-intercept is 100. So this has no solution. It doesn't have any x-intercepts. No x-intercepts. We would say that this actually, more specifically, has no real solution. We now know it has two complex imaginary answers. So our answers are imaginary. It's plus and minus 5i, because this doesn't actually cross the x-axis. These solutions are on a different coordinate plane. That's it. Do it like normal, put an I in it. Any other questions? Alright, so an I in your answer is an indication that your parabola didn't touch your x-axis. It was up here or it's down here. An imaginary answer. Alright, one more. I'm gonna do number. I'm gonna do example 5 tomorrow. What time is it? Alright, you guys know what? Let's do both example 4 and 5 tomorrow. I want to actually just give you some practice. I want you guys to get through all 12 of these today. Just simplifying radicals. So in your notebook, don't put your notes away. I'm going to walk around and give you credit for doing it right now. But so in the workbook, unfortunately, they're going to see some more challenging problems there. But I had to take a minute and just do these, right? In the workbook, you're going to see variables. I didn't get to variables today. I want you to try it anyway. You're going to see a fraction. Just do your best. We'll talk about it tomorrow.